Now it is okay. Voice is
sir.
okay.
Yes,
Right.
sir.
Yes, sir.
Right. Now you see, observe beta, only one. This is a carboxylic functional group actually. When you write COOH, what you can write C double bond OH like this, or you can write what COOH like this. Both forms are okay. Both are correct only, right? You can write like this, or you can write like this also. Now, if you have only one carbon, including what? This carboxylic acid. If you have one carbon, meth plus ane plus oic acid. You see, meth plus ane oic acid. Now you are having how many carbons? Wait, I have two carbons are there. So you have to call what? Eth, ane, oic acid, ethanoic acid. And if you have three carbons, pro, ane, oic acid. That means in all the cases, ane plus oic acid is what? Common for you. Only what you are changing here, root word you are changing. Root word, one carbon, methanoic acid, two carbon, ethanoic acid, three carbon, like that. Even you see what happened, butanoic acid also same like this. So these are the first four carboxylic acids. Now when you have a substituent like this, I am writing this substituent in this way, like this, CH3, this one I am writing here, okay, CH3, and what happens, CH, here also what happens, CH3. This is the thing they are taken actually. Now here, always we have to start numbering from carboxylic acid, because the carboxylic acid is the highest priority among whatever we are having in the functional groups in our syllabus. So that is the reason what happened, carboxylic acid should always get number 1, then what, 2, then what, 3. Now second carbon is having methyl, therefore 2 methyl, isn't it? And remaining what happened, how many you are having? 3, prop, ane, oic acid, ane, oic acid. Therefore you can call this one 2 methyl propanoic acid. Now, what about the common names for this one? This, you see, second carbon is having methyl. So what we can use here? Iso. Therefore, iso nomenclature. And total number of carbons you have to take. 4 carbons are there. Isobutyric acid. Isobutyric acid. In this way, we can give nomenclature. Isn't it? This is called formic acid. This is called acetic acid. You see what happened? Formaldehyde. Acetaldehyde. Formaldehyde looks like this. HCHO, formaldehyde, CH3CHO, acetaldehyde. So these two derived from this one only. Formica. Formica means red ant, isn't it? So it is derived from the formica, therefore formic acid. Now this formaldehyde is derived from the formic acid actually. They are what actually having same number of carbons actually. Similarly, acetic acid, acetum, isn't it? Acetum from the vinegar, isn't it? Acetic acid, it is derived from the vinegar, acetum, which is nothing but what, vinegar. So from this what happened, we got acetaldehyde. After that what happens, same nomenclatures we will get, propanoic acid, butyric acid, like that. Next, if you observe what happened, when you have two carboxylic acids are adjacent like this, then they are called oxalic acid, right? And if these two are separated by only one CH2 group, that is called what? Malonic acid. If they are separated like this, CH2, if you write like this, CH2, here it is what? COOH and COO. This is called what? Succinic acid. It is called what? Succinic acid, this one. When you write one more CH2 group here, again add one more CH2 group like this. CH2 like this. And you are getting a COOH. Here you are getting what? COOH. Now this is called what? Glutaric acid. When you increase one more CH2 group here, that is called adipic acid like this. Now when you observe this one will take here. How to give nomenclature for this type of molecules? Let me see one more. I am again writing the structure here. HOOCOOH, CH2, CH, and here we are having a carboxylic group here, right? Next, what happened? You're having CH2, COOH, right? Now, how to give nomenclature for this type of things actually? IUPAC nomenclature. Whenever, if I told you in the last, in carbonyl compounds also, when the functional groups are repeated what? 2 or more times, give numbering for that one. On which carbon these functional groups are there. On which carbon these functional groups are there. In the previous case, if you observe what happened, we have given numbering from where actually from here like this. 1, 2, 3 like. But what I am doing here, if you have more than one functional group like this, that means same type of one functional group. Carboxylic acids are three times is given like. In that case, here this is attached to this carbon. 1, 2, 3. On first carbon, carboxylic acid is there. On second carbon, carboxylic acid is there. On third carbon, carboxylic acid is there. Now, what happened here? On total number of carbons are how many? 3. So, prop. Next, between the carbon, single bond, ane, propane. Now, I am retaining this E because this T is not a vowel sound. So, you can retain this E. Compulsory the vowel you can retain. Now, on which carbon you are having? First carbon, second carbon, third carbon. How many there are? 3 types. Tri. What are they? Carboxylic acid. Carboxylic acid. In this way, we can give action. For example, if you don't have any COOH group, just imagine if you don't have any COOH group, what we have to give? Propane 1,3 dicarboxylic acid. If you don't have here any COOH group, what you have to do? Propane 1,3 dicarboxylic acid you have to give, right? So this is important for you. This type of nomenclatures will give you some exercise also is there in that last. You try that exercise here. I mean, if you get any doubts, you can ask in next class. Understood here? Now here, when you write like this, what you are calling beta? When you write benzene over CHO, what you are calling this one? What is the name of this one, beta? The name of this one will be benzaldehyde. Similarly, if you place here what happened? COOH here. This is called what? Benzoic acid. This one. Benzoic acid. Benzaldehyde, benzoic acid. You can also call benzene carbaldehyde. No, if you write what happened here, what we can call this one? If I write like this, CHO. We can also call this one benzene carbaldehyde. Benzene carbaldehyde, we can call this one. Benzene carbaldehyde. Similarly, we can also call this one benzene carboxylic acid. But generally, nobody uses this nomenclature, benzene carboxylic acid, because it's a lengthy. In short, we can call benzoic acid. In short form, we can call benzoic acid. Now, you have taken in the last class like this, pH, CH2, CHO. You have called this one what? Phenyl acetaldehyde. You have called this one what in the last chapter? We have called this one phenyl acetaldehyde. Phenyl acetaldehyde. Correct? Which is a common name. Now this one is called what? Phenyl acetic acid. Because it is having phenyl group, right? Generally CS3COOH is called what? Acetic acid. This is called what? Acetic acid. So instead of what? Calling acetic acid, why you are calling phenyl? Because one of the hydrogen is replaced with what here? A phenyl group. One of the hydrogen here replaced with phenyl. Okay. And otherwise, how to give IUPAC nomenclature? Number 1, number 2. Now 2-phenyl ethanoic acid. So this is very, very important. This one is very, very important one. This one also important one. And this one is very, very important. It will come in preparation of what? Amides. So that is the reason it is very important. Phthalic acid. All of you please remember phthalic acid. One more I will explain here. It is not there, but we'll take this one. COOH is here and COOH is here. Now when you observe here, COOH on ortho position, right? On ortho position. Here it is meta positions. Now this is called isophthalic acid. Isophthalic acid here. Isophthalic acid, right? But if I place like this here, COOH at para position, I'm making it. At para position, I'm making one more COOH group. This is called what? Terephthalic acid. Terephthalic acid. Isn't it? Terephthalic acid it is. So these, isn't it? Phthalic acid, isophthalic acid, Terephthalic acids, which type of isomers? Anybody? Can you say which type of isomers they are? In example?
Functional.
Yes?
Positional.
Positional isomers. Very good. It is a positional isomers because the position of the functional group is different here. Therefore, it is a positional isomers. So all of you try some today. Do some practice on IUPAC nomenclature, right? Next structure, it looks like this. What happened? Structure, what happened? How we write here? C double bond O, isn't it? OH. Why I'm writing like this? Because this sp2 carbon no better. This is sp2 because when you have a pi bond is there, whenever you are having a pi bond is there here, because of the pi bond, what happened? sp2 hybridization, its bond angle will be 120 degrees and planar structure. That is the reason we are writing like this, because of the planar structure. This is the planar structure. Trigonal planar like this. Trigonal planar like this. That is the reason we are written like this. Okay. Now when you will get a doubt actually whether this carbon is having electrophilic center or not. When you observe this is a ketone, for example, if you observe it's an aldehyde or ketone. Now definitely we get a positive character here, we get a negative character here, right? So nucleophile attacks at which carbon? This carbon. So generally aldehydes and ketones undergo which type of reaction beta? Which type of reaction? Because of this nucleophilic addition reaction. Nucleophilic addition. Because of this reason, nucleophilic additions are taking place on the carbonyl compound. Now, question arises here whether carboxylic acid will undergo nucleophilic addition or not. Let me see this one better. Now, what I am writing here? Lone pair I am writing. Because of oxygen is having definitely lone pair. Now, you observe your lone pair and pi bond are in conjugation. Whenever conjugation is there, they undergo resonance here. So we are going to get this type of structure. This type of structure we are going to get. RCO minus double bond OH here. Double bond OH, because oxygen donated lone pair to carbon, therefore oxygen get a positive charge. Now, do you have any positive charge here? There is any positive charge here? No. So in this case, what happened? Nucleophilic additions never takes place on this carbon. So nucleophilic addition could not take place here. Impossible it is. So in examination, if they ask what happened, carbonyl compounds are undergo nucleophilic addition because of absence of resonance, whereas carboxylic acids do not undergo nucleophilic addition because of the presence of what? Resonance. Okay, this type of questions also they may generate, because based on these resonance structures, they may generate this type of question. Now, these are the IUPAC nomenclatures we can give. I will write 2 nomenclatures, remaining you can do this one. So first one, numbering you have to do. 2, 3. Anybody, what is the nomenclature of this one? By a given number. Anybody possible?
Three-phenyl propanoic acid.
Very good, better. 3-phenyl propanoic acid. Okay, right. If you give numbering, then you definitely will get everything. Now, this one, is it possible? Definite. Second one, I'm giving numbering for this one. C double bond CH COOH. Now, here actually this carbon is having a methyl group here, and one more methyl group is here like this. Now, numbering must be done like 1, 2, 3, 4. So it is called what? Tell me. Anybody?
3-methyl-butanoic acid.
Right. 3-methyl-butanoic acid. Right. 3-methyl. Total number of carbons are how many? 4. But-2-ene-oic acid. Correct. For this one, no need to give 1 oic acid, no need, because it's always at the last one. Now, for this one, you have to give numbering from this one. 1, 2 like this. Now, the nomenclature, I will explain this one. Nomenclature. Actually, it is called 2-methyl. Second carbon is having methyl, therefore 2-methyl. Now, this one is cyclic ring, no? Cyclo. And how many carbons are there? How many carbons are there, beta?
5.
For what happened? Pentane, cyclopentane, right? 2-methyl cyclopentane, correct? Then COOH is there, and which carbon? First carbon, no need to write here. Now we have to remove this one is the OE carbon. No need to remove this E. Why? Because you are not including this one in the root word. When COOH is not including in the root word, write down as a carboxylic acid. Cyclopentane, carboxylic acid. Carboxylic acid. Because you are not including this one in what? Root word. If you include in the root word, what you have to call? OEic acid you have to call. If you include something, what happened? CS3COOH, you are acid. But the COOH is not including in the root word. Root word, what I have taken here? Pentane. So pent means these only carbons I have taken. These are the 5 carbons I have taken, right? And here the numbering got to start from here because carboxylic acid is the highest priority. Second, you go from here. Why? Because you will get no problem. Anywhere you can use because it is symmetrical molecule. You can cut it to equal parts. No, here. So anywhere you can give from here also from here. I am giving some this direction. 4, 5, 6. Now in this case, it is called 2,4,6 trinitrobenzoic acid. What you are calling? 2,4,6 trinitrobenzoic acid. Trinitrobenzoic acid. Why? Because just now I told you benzoic acid. This is the benzoic acid which can be taken as what? IUPAC nomenclature. Benzoic acid. You observe here what happened? Benzoic acid can be taken as what here? IUPAC nomenclature. Right? So we can take this one as benzoic acid here. Okay, and remaining 2,4,6 trinitrobenzoic acid. Okay, these are the simple nomenclatures I have taken. At the last of this chapter, you have some exercises there. Try this IUPAC nomenclatures. Right? Next, we will now move to what some preparation methods here. What are the general preparation methods of carboxylic acid? Today we complete these preparation methods only. Now, from primary alcohols, by using the primary alcohols and aldehydes, we get what actually? Carboxylic acid. Now, what are the reagents we are taking actually? Now, when you take a primary alcohol, they definitely convert into what here? Carboxylic acids. Now, what are the reagents we are taking for conversion of primary alcohol? I am writing here better. Primary alcohols can be directly converted. This we already discussed in that one. You will get this one. Primary alcohol convert into carboxylic acid. Already we have done this one. Where in the chemical properties of what? Aldehydes, even in the chemical properties of alcohols also we discussed that one. Again, we'll discuss this one. Now, what are the reagents we can use here? Potassium permanganate, KMnO4. KMnO4. Isn't it? Potassium permanganate. Otherwise, what happened? Potassium dichromate. K2Cr2O7. K2Cr2O7. And we can also take what happened? Jones reagent, chromium trioxide in presence of H2SO4. Isn't it? So these are the 3 reagents which can convert a primary alcohol. For example, I am writing CH3CH2OH I have taken. Right? Now, if you treat this one with what? KMnO4 here. KMnO4. Now, what happens if you observe what happened? This CH2OH will convert into carboxylic group. CH3COOH. Acetic acid is formed. Now, you try this one. All of you try this one in your notebook. CH3, CH2, and again CH2OH. If you take. These all are primary alcohols. Now, if you treat this one with what? You take another one, K2Cr2O7. K2Cr2O7. Tell me the name of the product, all of you.
Butanoic acid.
Propanoic acid beta. Propanoic acid. Because when the number of carbons will be same only. See how many carbons are there beta? 3 carbons. In the product also will get 3 carbons only. But in terms of what? Carboxylic acid. So propanol, right? I am writing propanol. Okay. Propanol will convert into what here? Propanoic acid. Propanol will convert into propanoic acid here. Correct? Understood? Any doubts you're having in this one?
No, sir.
No, sir.
One more thing, if you observe, decanol. Deca means 10 carbons you are having. 10 carbons you are having. Decanol will convert into decanoic acid. For example, you take pentanol, you take pentanoic acid. Hexanol, if you take hexanoic acid, you will get. So this is what conversion of primary alcohol into carboxylic acids. Okay. Now what about the aldehydes? We have taken mild oxidizing agents. What are they? See, Tollens reagent. Aldehydes, we have taken what PCC, not PCC, Tollens reagent, Tollens reagent, or Fehling's reagent. You got RCOO minus. For this one, if you add any H plus, they will convert into carboxylic acid. Okay, so take Tollens and Fehling solutions in chapter carbonyl compound. Now we move to what second one, alkyl benzene. This same thing where we got in the preparation of what? Same method we take. Do you remember that one? From alkyl benzene, we have prepared what? Benzaldehyde. We go for what? Last topics here. From alkyl benzenes, we have prepared benzaldehydes. Which reactions we have taken? Itard reaction we have taken. Gattermann-Koch reactions we have taken in the topics. No, Itard reaction is a very best example we have taken. Conversion of alkyl benzene into benzaldehyde. Same we are also doing like this. Same thing we are doing like this. That reagents are different. At that time, the reagent will be what here? Acidic anhydride we have taken. But here we are taking what here? KMnO4 in presence of base here. Now, you observe here one thing here. Whatever number of carbons you take, the final product will be same. I have taken here methyl benzene. I have taken methyl benzene. One carbon is outside here. If you take ethyl benzene, you take what? Ethyl benzene here. CH2. Just a minute. Just a minute. CH2, CH3. I am taking what? 3 carbons now here. I have taken how many? 3 carbons I have taken. Now all these things, if they undergo oxidation reaction, if they undergo what happened? Oxidation reaction with either KMnO4 or K2Cr2O7. Okay, KMnO4 or K2Cr2O7. Or you can take what happened? Chromic acid. Chromic acid means we can write like this. Chromic acid means H2CrO4. This is called chromic acid. H2CrO4 is called chromic acid. Or acidic alkaline potassium permanganate. This means nothing but you can take KMnO4. You can take it. Now what happens here? This will convert into carboxylic acid. Understood? Even if you take 2 carbons or 3 carbons, all will convert into what here? 1 carboxylic acid only. All will convert into 1 carbon. You see here, I have taken here toluene. I have taken. What I have taken here? Toluene. Number of times we got this one. Methyl benzene. Now, when you do reaction with what? Oxidation with KMnO4 in basic medium, followed by hydrolysis reaction, you are going to get the benzoic acid. Even though if you take what happened? Propyl benzene. The name of this one is called what? Propyl benzene. IUPAC name only it is. Propyl benzene. You're getting again same benzoic acid only we get. If you take what? Ethyl benzene. This is called what? Ethyl benzene. When you take ethyl benzene, same product you are going to get. So it is very simple for you, isn't it? Any doubts you're having in this second part, beta?
No, sir.
I will move to what here? Third one, from nitriles. Nitrile means cyanides, beta. What is the meaning of nitrile? Cyanides. By using the cyanides. Very, 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 very important one, isn't it? Number of times this question they're asking. Not directly in conversion. This question you will get only in conversions only. Very simple to identify. Now, I will explain this one by taking one example. Like if you see something what happened, you don't get anything. I will explain by taking what a simple thing actually. Now it can be do with acidic hydrolysis. You can do with what? Basic hydrolysis. If you use H plus, that is called acidic hydrolysis. If you use OH minus, that is called what? Basic hydrolysis. Now let me see what acidic hydrolysis, how it looks actually. Very simple. I'm writing here R C triple bond N. This is the cyanide group. Which one? This part. First of all, I will make mechanism. After that, we'll see this shortcut for this one. Now, what is the mechanism here? Now, do hydrolysis reaction. In hydrolysis, we have to add H plus and we have to add OH minus. Now, add one OH minus here and one H plus here. Again, do one more times. One H plus here, second OH to this. That means this carbon is getting the C is getting what? How many OH groups here? Two OH groups here. Two OH groups here. And this nitrogen is getting how many hydrogens here? Two nitrogens you are going to get. What I have done actually? To this carbon, I have added two OH groups here. To this nitrogen, I have added two hydrogens because here 2H plus, 2 OH minus. Now remove the pi bonds. All the pi bonds you remove, keep only sigma bond. Now already you know, if a carbon having more than two OH groups or two or more than two OH groups, in that case, it undergo dehydrolysis reaction. Now this bond will be shifted over here and this bond will be removed here. So we are going to get like this. R, C, double bond O, NH2. This is called what? Amide. Here it is right. Okay. Now, again, if you do, this is partial. Generally, conversion of to this one is called what? Partial hydrolysis. Not complete. It is called partial hydrolysis. We call this one what? On partial hydrolysis reaction. Mild reaction conditions. Partial means what? Mild reaction conditions. We are getting what actually? Amides we are getting. But if you do complete hydrolysis, one more time if you do here, one more time again, add H plus and add OH minus. Now add H plus to where here? Add H plus to here and OH minus where we are adding beta? On carbon. Now what we are getting? You break this bond also. Last bond you break. Now what we get here? RC double bond OH. Okay, this OH we are adding to this carbon and you are breaking this bond. Now NH2 is gaining one hydrogen, that is converting into here what? NH3. Now you got this type of NH3, you see. Now this is the product we are going to get. Have you understood this product? How to write this one? What actually we done better? We removed the two pi bonds here. To this carbon, we have added two OH groups. To this nitrogen, we have added two hydrogens. After removing these two pi bonds. And after that, what happened? This carbon has two OH groups. Now shift this bond to here and remove the OH completely. Now what we get here? RC double bond to NH2 we get. Finally, if you do one more time hydrolysis reaction, we are completely breaking this bond and putting one hydrogen to the nitrogen and OH to the C double bond group. We got this product. So this is the mechanism. Understood this one?
Yes, sir.
Now I will make what happen a shortcut for this one. How this one? Let me see this one here. We'll take a shortcut here. Now, for example, if I write like this. What I'm writing here, CS3CN. Now, very simple you have to do here, H2O. What I'm adding here, H2O. Now, what we have to do, two hydrogens. Listen, this is a shortcut, not mechanism. Add to nitrogen and one oxygen. We're adding to what here? Carbon. Now, what we are going to get, CH3, C, N. Now nitrogen is getting what beta? 2 hydrogens. Write down the 2 hydrogens. And carbon is getting oxygen. No. Put that oxygen over like this. Put that oxygen over like this. Amide is completed. Next, after this, what happened? Doing second time, adding water again. Adding again water. In this case, what happened? You write water like this, H plus and OH minus. Now add hydrogen to this one, add OH to this one. Now break this one also. We are going to get here what? CH3, C double bond OH plus what happened? Ammonia. Okay. So up to here it is called partial hydrolysis, and this one is called what? Complete hydrolysis. Right? For example, I have taken like this here. PH CH2 CH2 CN. I am doing complete hydrolysis. Okay. I am adding what happened? H plus in presence of water on complete 3 moles I have taken. Complete hydrolysis. What you have to do in place of cyanide? What you have to keep here actually? Keep here what? CH2 CH2 COOH. That means in the place of cyanide, you are getting what here? Carboxylic acid. Directly we are writing cyanide is converting into what here? Carboxylic acid. In this way, you can write many number of examples. This is useful for you. This one is useful. What I have told you, 2 hydrogens to the nitrogen, 1 oxygen to the carbon, but you keep like that here. You will get everything actually. But you need to practice more number of times, then only it will be easy for you. Observe here what happened. They taken what? Amide. 1 only they taken, ethanoic acid. You see, CONH2 converting it directly into carboxyl. That means cyanides, first they will convert into amide. All these are what? Amides only. All these are what? Amides only. Amides again further if you do hydrolysis reaction, you will get the carboxylic acid only, isn't it? Now we'll see what grignard reagent. This is very simple. I will complete this one within 2-3 minutes from grignard reagent actually. So one grignard reagent will discuss on. So how to discuss this grignard reagent? Let me see now here. You see, I am taking here what? RMGX. Here I am taking what here? RMGX. Grignard reagent RMGX. Reacting with carbon dioxide, C double bond O, C double bond O. Reacting with carbon dioxide in presence of what? This is also called dry ice. Generally we call carbon dioxide is called what? In the form solid state. Carbon dioxide in solid state is called what? Dry ice, because it converts directly into gas without into liquid state. That is the reason it's called dry ice action. Now what happens here? R is having negative character, attacks over the carbon, isn't it? Now this pi bond will be shifted over here. We are getting what here? R, C double bond O, O minus. And this MgX will come here because it's a positive charge, will come actually. R MgX. After that, add H plus to this one. Add H plus in terms of what? Water here. Addition of H plus. Hydrolysis. Now add H plus to this one. Now we are going to get here R, C double bond OH. And this will be what? Completely removed here. MgX will be completely removed. We'll take one example here, CH3 MgX, CH3 MgX, reacting with carbon dioxide like this. Now what we are going to get? Now CH3 is what here? Nucleophile, attacks over here this one. Now we are going to get CH3 C double bond O, isn't it? MgX here. Now we are going to get here what? CH3 C double bond O, OH. When you add H plus, you are going to get like this. Okay. Now, for example, I will take one more example here. Shall we take one more example here? Last example we'll take for this one. Now, if I take what happened, CH3, CH2, MgBr, I'm taking MgBr, reacting with carbon dioxide. Now, what is the product name, beta? Anybody? What is the name of the product?
Propanoic acid.
Propanoic acid. That means what we have to do here? Here 2 carbons are there. Add 1 carbon and call with carboxylic acid. So 2 carbons already is there. 1 carbon you are getting. So it is called what? Propanoic acid. You try this one, you will get only this one. CH2COOH. For example, if I take something like this PH I'm right, MgBr. Phenyl magnesium bromide, grignard reagent, reacting with carbon dioxide. Now, what is the name of the product?
Benzoic acid.
Benzoic acid. Because this phenyl is nothing but like this, no? This one. Attacking over the carbon, what we get here? Benzoic acid. We get this one. For example, if I write like this, pH, CH2, MgBr, reacting with carbon dioxide. Now, what is the product we are going to get here? What is the product we are going to get here?
Phenyl ethanoic acid.
Very good. Phenyl ethanoic acid. That means this part you have to retain. This part you have to retain here. You have to write compulsory pH2 CH2, and this part will convert into carboxylic acid. Finished. This part will always be there, and whatever joined with magnesium, no, that part we have to add here. Don't add to this one. Add whichever is binded to magnesium. So carbon dioxide you are adding here. So we got PSCH2CO. Very simple or not? But thing is that you have to practice. Otherwise, you can't remember for this one. Long time you can't remember this one. So this is about the grignard reagent beta. It's a very, very important one, right? So here only we discuss. Tomorrow we'll see the remaining preparation method, 5th and 6th methods. We'll see in this one. And if you observe what happened, some of the exercise given, butanol, CH3, CH2, CH2, CHO. This is butanol, converting into butanoic acid. So which reagent generally will take beta? Converting into any oxidizing agent, KMnO4, K2Cr2O7, they will convert this one into like this. So this cyclohexane is in the 11th class is there. Wherever double bond is there actually we are going to get like this. Wherever double, this is there in the 11th class actually. Cyclohexane, this is called cyclohexane. Now, wherever the double bond is there, break that one. In that case, we are going to get like this. Wherever double bond is there, here double bond is there, that will convert into what here? Carboxylic acid. That will convert into what? Carboxylic acid. Generally done by B2O5, isn't it? When you break this one, you will get like this. And 4-methyl estophenone to benzene 1,4 dicarboxylic acid. 4-methyl estophenone, CH3. देखो बेटा CH3 estophenone, how you write here? This is called estophenone, correct or not beta? Is it called estophenone? Correct or not? Right.
Yes, sir.
Now what? 4-methyl estophenone. This is called what here? 4-methyl estophenone. Now if you do oxidation with KMnO4, now what happens here? Now here already we discussed this part here. You observe here this part already we discussed, no? This one. Methyl group will convert into what here? You observe here what happened. Methyl group is converting into what here? Carboxylic acid. Same method you follow here. Isn't it? You follow same method. This will convert into what here? Carboxylic acid. Not only that one, even this carbon also will convert into carboxylic acid. Whatever the carbons are there, they convert into carboxylic acid. Now this is called, I told you this one is terephthalic acid. The name of this one is terephthalic acid. Isn't it? This is the IUPAC name, a common name. IUPAC name will be 1, 2, 3, 4. Therefore, benzene 1,4 dicarboxylic acid. Similarly, you can do remaining also very simple you can do. So try these problems, isn't it? Conversions if you want to do, you can do this one, isn't it? So you try this one. I will. If you have any doubts, you can ask me better now. You have any doubts now? Do you have any doubts? No doubts?
No, sir.